Okay, so today we're going to talk about atoms, molecules, elements, and compounds. And this is just kind of an intro to get you into understanding the periodic table and a little bit about the things we're going to use. So the first thing I always have my kids do is model H2O. Now, we've all heard of H2O, so like the first thing that usually kids think of, and I usually have them draw a before picture, a lot of kids will give me things like water, like in the ocean. They may give me a water droplet or two, or they may just give me a glass of water. Okay, and all that is true, okay, but when we're in science class, we're going to be more specific and we're going to zoom in and see what H2O really looks like. All right, so H2O is just the chemical, okay, formula for water. Okay, we all know that it's water. We've heard it our entire lives, but it's this chemical formula. It's how we make water, okay? So the first thing we need to understand is we need to understand that it's made up of atoms, okay? And I know I talked about that in my last video a little bit, that we were going to get more into this. And atoms are not very complicated. It's another word that you've probably heard and maybe you just don't understand completely. But just know that atoms are very, very, very tiny. Like so tiny that they are the smallest things on our planet, in our solar system, okay? They're incredibly, incredibly tiny. We're never going to see these with our naked eye. They're going to be too tiny. So like even if I put this one dot, I don't know if you can see that, that's little tiny dot on my piece of paper, this is made up of hundreds and thousands of atoms, even though I can barely even see it, okay? So tons of atoms. Sometimes people use a different word and they'll kind of call them particles. Okay, that's not as scientific, but it kind of gives you that idea. They're little tiny things. And there are lots of different names and types that we can use, okay? But like I said, they're the smallest things on Earth, okay? Nothing is smaller than atoms, okay? Because atoms make everything else, okay? These atoms will eventually start joining together and they'll become other things, things that we can actually see, okay? Because they're really tiny right now. All right, now throw in some more vocabulary words at you, okay? Sometimes we get fancy, all right, and we give atoms names, okay? And when we start naming them based on like what they do or what they can do, I guess, we start calling them elements. Okay, elements. Now, you've probably heard of this because you have probably seen something that looks like this. Okay, we've seen it in movies, we've seen it in videos, you've heard of it, and it's in like all of our science textbooks or maybe in the back of like agenda books and different things. This is the periodic table of elements. So this is the thing that kind of organizes it, and there is a reason to how it's shaped, how it's formed, but as a sixth grader, we're not going to get too into that right now, okay? But just know that these are all of the elements or the types of atoms that we have in existence. Here on Earth, these are the ones we know about. And so what's really cool, all right, is that everything in the world is made up of these things, okay? These types of atoms, these things we call elements. Now, there are 118 different types of elements that we know about, okay? So there's 118 of them, and these, again, we just call elements. All right? It's pretty cool. All right, let me put this over here. All right, so if we zoom in and we start talking about the periodic table, okay? Each one of these, there are certain things that we're going to notice about them, okay? If you're looking at a periodic table, okay, every one is going to have an atomic number. Looks like the word atom. That's on purpose because it's a type of atom. All right, so they give it a number, and now they go in order with your numbers. So it goes like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on and so forth. Now, what's weird about it is you have two like blank ones right here, okay? And like I told you, there's a reason for the madness of how they organize all of this. But if they were to keep following that pattern, okay, all of these down here would fit in these two boxes right here. And that would make my periodic table really, really, really long. And so they kind of cheat. Think of it like when you're writing something and you forget a word and you use that little caret to say, I forgot the word and. It's kind of what they're doing right here. Okay, so there are 118 of them. They're all going to have this number at the top, okay? They're all going to have this symbol, Okay, they're going to have a symbol. And then they're going to give you the fancy name or the real name that they actually call it. Now, you're going to notice that some of them match. They look alike. So like carbon, okay, uses the letter C as its symbol. Okay, that one makes sense. This one, not so much. Sodium is Na. Okay, so what you have to remember is like when the periodic table was designed, they didn't speak English. They spoke Latin. Okay, so the word is actually based on, the symbol is based on their Latin word, not their English word. So if you notice some that don't match, don't freak out. That's just the symbol that they use. And it's based off of a different language, not English. Okay, but if you're looking at them, you're going to notice that every single element on that periodic table starts with a capital letter. All right, there are no exceptions. All of them start with a capital letter. So you have like TI, TC, RG. Okay, do you notice how they're all starting with capital letters? This is very important, okay, because when we use those symbols and when we talk about them later on and we start using these symbols, if it's capital or lowercase is going to matter. So I need you to be very specific and paying attention to if you've got capital letters or not. Okay. All right. So if it starts, if it always starts with a capital letter. Now, some of these have one letter. Okay. Some have more than one letter. Okay. If you have more than one letter in your symbol, it will always be lowercase. Always. Okay, no exceptions. So again, we're going to look on here like this one, that my second letter is an E and it's lowercase. If we're up here, my second letter is an S and it's lowercase. There are a few that have 3 letters, and if it's past the first one, it's lowercase, lowercase, lowercase. And this just helps us distinguish or tell how a new element starts. A new one always starts with a capital letter. Okay, always, always, always. And then if you have that other letter, it just means that it goes along with it. Okay, I like to think of it as like if you're talking about a lowercase letter, it's like a little kid crossing the street. It can't go by itself. It's got to go with the adult. The capital letter is the adult, and so it gets stuck with it. So if you see a lowercase letter and you're seeing the symbols, it means it goes with this, and it's the same symbol for an element. Okay. All right. So if you get a chance, just look over your periodic table and make sure that I'm true on this and that I'm not lying to you. And it is pretty cool. And there are lots of really, lots of just random weird words, I guess you might say, or types of elements. Some of them we've heard of, like you've probably heard of hydrogen. Okay. You've heard of gold or silver. Okay. Maybe you've heard of titanium, but there are some on here that we haven't heard, like this one, dubnium. I don't even know. I can't even pronounce it because it's so weird to me. Okay. Or like boron. You've probably never heard of boron. Okay. But they do exist and they are on that periodic table. Everything in the world is made out of these 118 things. Okay. These 118 things are the building blocks of everything else. Okay. So when atoms start combining, okay, when atoms who are hanging out by themselves start combining with other atoms, we get new things. Okay, so here I'm showing you that they're combining. Now, the symbol is a capital letter, so I have to make sure that I'm using a capital letter in this. Okay, so when you have atoms and they're joining with other atoms, we get these things called molecules. All right, again, we've heard of this before. All right, and this is how we get more stuff on the earth than 118 things. Because remember, there are only 118 types of elements. And so they have to rearrange themselves and be friends with other people just so that way you can make new stuff. Okay, so when 2 or more atoms, and here's the fancy word for it, chemically combine, we get these things called molecules. All right, we get these things called molecules. All right, so let me show you some examples of molecules here. All right, if I have, and I did this one up at the top here, 2 things that are stuck together, and you see that I have them touching, that means that they're chemically combined. Okay, this is a molecule. All right, water, which we know is H2O. Okay, now this time we have more than 2, but it says 2 or more. Okay, 2 or more atoms. So this is more than 2 atoms. They're chemically combined. I'm showing that they're stuck together. This is a molecule. Okay, you may also see a molecule drawn like this. Okay, now these are still showing that they're combined. Okay, this is what they might call a stick model. And when you get into upper level chemistry classes, the number of lines that connect them will matter. But for this case, all right, they are connected. They're stuck together. They are chemically combined. This is a molecule. Okay, if they're hanging out by themselves, and let's say that this is a boron atom and this is a boron atom, okay, these are not stuck together, so these are not chemically combined. This is not a molecule, okay? This is 2 separate elements, okay, that are just hanging out by themselves, okay? This is just a little bit of an intro. We'll practice a little bit more later on.